Dear students, myself Dr.C.Chandrasekar, Professor, Department of Computer Science, Periyar University, Salem. Today we are going to discuss about GSM system architecture. At the end of the session, students will be able to identify services provided by various subsystems in GSM system architecture. The diagram shows the functional architecture of GSM system architecture. GSM system architecture has divided into three main components, that is radio subsystem, network and switching subsystem, and operation subsystem. The radio subsystem, that is called RSS, it consists of mobile station, base transceiver station, that is PDS, BSS base station subsystem, BSC base station controller. Network and switching subsystem consist of mobile services switching center, home location register HLR, visitor location register VLR, gateway MSC, and interworking functions. And operation subsystem consists of equipment identity register, authentication center, and operation and maintenance center. Radio subsystem, the radio subsystem comprises all radio specific entities, that is the mobile station and the base station subsystem. It shows the connection between the RSS and the NSS via the A interface, that is solid lines, and the connection to the OSS via the O interface, that is dashed lines. Let us see one by one. Base station subsystem, the BSS performs all functions necessary to maintain radio connection to an mobile station, coding, decoding of voice, and rate adaptation to and from the wireless network part. The BSS contains several BTS. The next one is base transceiver station, that is PTS. A PTS comprises all radio equipment, that is antennas, signal processing, amplifier necessary for radio transmission. A PTS can form a radio cell or using sectorized antennas, that is several cells, and is connected to mobile station via the universal mobile interface. Base transceiver station, the PTS, it will do both the function, that is transmission and receiving. So it will transmit the signal from tower to mobile station, as well as it will receive the signal from mobile station to tower. The next one is base station controller, that is BSC. The BSC basically manages the PTS. It reserves radio frequencies, handles the handover from one PTS to another within the PSS, and performs paging of the MS. The next one is mobile station, that is MS. The MS comprises all user equipment and software needed for communication with a GSM network. On mobile station consists of user independent hardware and software and the subscriber identity module, that is SIM card, which stores all user specific data that is relevant to GSM network. So the user can personalize any hardware, that is you can purchase any type of hardware like Samsung or Apple or any other third party vendors. Each mobile station, that is MS, having a separate IME number, that is International Mobile Equipment Identity. A user can personalize any mobile station using his or her SIM card. That is, user specific mechanism like charging and authentications are based on the SIM, not on the device itself. Device specific mechanisms, example theft protections, use the device's IME number only. Mobile stations can also offer other types of interfaces to users with the display, loudspeaker, microphone, and programmable soft keys. Further interfaces comprises, that is we can access the Wi-Fi network as well as the Bluetooth network. So the mobile phones comprises many more vendor specific functions and components such as cameras, fingerprint sensors, calendars, address book, games, and internet browser, etc. The next one is network and switching subsystem. The network switching subsystem consists of MSC, mobile services switching center, home location register HLR, visitor location register VLR, gateway MSC, GMSC, and interworking functions. Let us see one by one. Mobile services switching center, MSC, it is a high performance digital ISDN switches. They set up connection to other MSCs and to the BSCs via the A interface and form the fixed backbone network of a GSM system. Typically, an MSC manages several BSCs in a geographical region. A gateway MSC, that is GMSC, has additional connection to other fixed networks such as PSDN and ISDN network. Using additional interworking function IWF on MSC can also connect to public data networks. On MSC handles all signaling needed for connection setup, connection release, and handover of connection to other MSCs. The standard signal system SS7 is used for this purpose. SS7 covers all aspects of control signaling for digital networks. Features of SSL7 are number portability, free phone, toll number, call forwarding, etc. An MSC also performs all functions needed for supplementary services such as call forwarding, multi-party calls, that is video call, etc. The HLR is the most important database in a GSM system as it stores all user relevant information. This comprises static information such as the mobile subscriber ISDN number, subscribed services, and the International Mobile Subscriber Identity IMSI. Dynamic information is also needed, example the current location area LA of the MS, the mobile subscriber roaming number MSRN, the current VLR and MSC. As soon as an mobile station leaves its current location area, the information in the HLR is updated. This information is necessary to localize a user in the worldwide GSM network. All these user specific information elements only exist once for each user in a single HLR, which also supports charging and accounting. The next one is Visitor Location Register VLR. The VLR associated to each MSC is a dynamic database which stores all important information needed for the mobile station users currently in the location area that is associated to the MSC. If a new mobile station comes into an location area, the VLR is responsible for it copies all relevant information for this user from the HLR. This hierarchy of VLR and HLR avoids frequent HLR updates and long distance signaling of user information. The third part of a GSM system architecture, the operation subsystem, contains the necessary functions for network operations and maintenance. The OMC monitors and controls all other network entities via the OI interface, such as traffic monitoring, status reports of network, subscriber and security management, accounting and billing. The second one is authentication standard AUC. As the radio interface and mobile stations are particularly vulnerable, a separate authentication standard has been fixed to protect user identity and data transmission. The authentication standard contains the algorithm for authentication as well as the keys for encryption and generates the values needed for user authentication in the HLR. The next one is Equipment Identity Register. The EIR is a database for all IMEIS. So IMEIS, it is a 15-digit number. It is a unique number for all the mobile stations. It stores all device identification registered for this network. On mobile stations or mobile, they can be easily stolen. With a valid SIM, anyone could use the stolen mobile station. The EIR has a blacklist of stolen devices.